Alright, in this video we're going to look at some more graph transformations. We already did shifting, up, down, left, right. These transformations are going to be a little bit less distinct. You don't necessarily have to plot points, but if you want a really good graph, you're probably going to use it in conjunction with shifts and maybe intercepts and things like that. We're not going to quite get into that detail, but usually these types of transformations are used with something else as well. But for us, we're just trying to get an idea of what these are going to look like, so this will give us a good idea of what we're looking for. Okay, so the first one that we're going to look at is what happens when we multiply by a number. So we looked at adding and subtracting. This time we're multiplying by a number. So I'm going to plug in those same values that we've been using. And when I plug in my x value, remember your order of operations, you're going to square and then multiply because exponents come before multiplication. Remember PEMDAS? So exponents, then multiplication. So this is going to be 2 times 4 is 8. 2 times 1 is 2. 2 times 0 is 0. 2 times 1 is 2. And 2 times 4 is 8. Okay, so like we looked at before, what's happening here is we're doing our x squared. It's the same things that we saw over here. We're doing our x squared, and then we're multiplying by 2. So we're doing 2 times 4, 2 times 1, 2 times 0, 2 times 1, 2 times 4. So what happens is all of your y values are going to double. So see how our y values have doubled from the original one? And again, we could look at a huge table of values and we would see that all of our y values have doubled. Okay, so take your quadratic picture, pretend that you stamp it on Silly Putty or Play-Doh or something like that, and then you're going to double all of your y values. We only have positive ones here, but if we had negative ones, they would double as well. Think about what that would do to your picture. Okay, if you think about it, that would stretch your picture, like you would stretch Silly Putty or Play-Doh. So all of your y values are going to double in this direction, and they're going to double in that direction. But 2 times 0 is still 0, so this is going to stay the same. So it's going to stretch the y direction. It's going to make your graph a lot taller than it was before. So I should have had a bigger graph here. We're going to have negative 2, 8. That's actually going to be off our picture. We're going to have negative 1, 2, we're going to still have 0, 0, we're going to have 1, 2, and then we're going to have 2, 8. That's going to be way up off there, like that. So look at what happens to our picture. It actually looks like it's getting skinnier, but it's not. It's actually stretching in the y direction, which for some graphs looks the same as a compression in the x direction, but we're not going to get into that for this section. Okay, so it's like we stretched our Silly Putty up and down. Okay, we made it taller. All right, so if we multiplied by 3, let me get this out of here because we're going to need the space. You can probably imagine if we multiplied by 3, that's going to multiply all of our y values by 3, and that's going to make it even taller and skinnier. So multiply everything by 3, and then we'd be going to 9, which is even farther off. Actually, I'm a little bit, I'm going to back this up a little bit here. I'm actually off in the picture. I'm not sure I'm going to be able to draw it accurately enough anyway. Okay, so then multiply to 3, multiply to 3. Okay, because we still have that U shape, and I'm looking a little V-ish when I try to draw this, but it's going to go like this, and it's going to go like this. Okay, so it never actually goes vertical, but it is going to get steeper and steeper the bigger that number out front gets. So let's add that to our general rule list. If we have y equals ax squared, and a is a number bigger than 1, then we stretch in the y direction. Okay, so we stretch our silly putty up and down. All right, let's try one that's less than 1. Less than 1. Let's do, what's a color we haven't done yet? We haven't done blue. Okay, let's do 1/2 x squared. 1/2 x squared and see what happens with that. So -2, -1, 0, 1, 2. And we're going to put 1/2 out front. I'm going to fill all these in here. Okay, so we're going to square it, and then we're going to take 1/2. So -2 squared is 4, half of 4 is 2. -1 squared is 1, and 1/2 of 1 is 1/2. 0 squared is 0, half of that's still 0. 1 squared is 1 times 1/2 would be 1/2, and 2 squared is 4, half of 4 is 2. So looking from our original black table to our new blue table, we see that all of our y values have been chopped in half. All of our y values have been chopped in half. So think about what that's going to look on your silly putty graph. If you chop all your y values in half, you're going to squish that silly putty. You're going to squish the silly putty by half this way. Okay, so that's going to squish all your y values down. It's going to look like it's getting fatter, but it's actually getting shorter is what's really happening. So we're going to have 0, 0, half, half, 2, 2, and it's going to look something like this. Okay, so this is 1/2 x squared. This was our regular x squared. This was our 2x squared. And this was our 3x squared. Alright, so let's get rid of all this and write our general rule. Okay, so if we're multiplying by a number out front, if it's bigger than 1, it's going to stretch in the y direction. And if it's less than 1, it's going to compress in the y direction. Okay, so when you stretch in the y direction, that has the effect of looking taller and skinnier. And when you compress in the y direction, it has the effect of looking wider or shorter. Okay, so stretch in the y direction makes it look more narrow. A compress in the y direction makes it look wider. All right, one more transformation that we're going to talk about. I should have left my x squared here. We keep using that, right? It all comes back to that basic one. We've got one more transformation that we're going to talk about, and that's what happens if we put a negative out front. So let's say that we've got negative x squared and see what happens with that. Okay, so what's going to happen here, remember exponents only go with what they're next to unless parentheses tell you otherwise. So this negative is not part of this exponent. The negative is on the outside. So when we plug numbers in here, order of operations says we're going to square them and then we're going to make them negative. So we've got to be careful on our order of operations, as always, but especially for this one. So when we do this, we're going to square it, we're going to get positive 4, and then the negative out front is going to make it negative 4. We're going to square it and get positive 1, but the negative out front is going to make it negative 1. 0 is just going to be 0 squared and negative, doesn't matter. This one's going to be 1 squared. Negative out front is going to make it negative 1. This one's going to be 2 squared is 4. Negative out front makes it negative 4. So look what happened to our y values. They're all going to be the same, but this negative out front makes all of our y values negative. So put your any graph on Silly Putty again, and take all of your y values and change positive to negative and negative to positive. Okay, so any positive y value goes to negative. Any negative y value goes to positive. Think about what's that going to do to your graph. It's going to flip the whole thing. Okay, so let's look at what happens. We still have 0, 0. We've got negative 2, negative 4, negative 1, negative 1, 1, negative 1, and 2, negative 4. So it's the same exact picture, but it's facing down. Okay, so if you put a negative out front, it's going to flip the whole picture so that it's facing down. So a number out front is going to be a stretch or compress. A negative out front is going to flip it upside down.